and I work at Anonymizer. We're going to talk to you about attacks on anonymity. What really happens in practice. So the first question that we need to ask ourselves when we're designing anonymity systems is, what attacks really exist? Or, more importantly, what attacks are our users concerned about? When we're building an anonymity system, we try to anticipate all the possible attacks and then try to come up with defenses against them. We're actually playing against ourselves here. We have a devil's advocate conversation going on. Okay, we build this, how can we attack it? All right, we can attack it this way, how can we fix it? Iterate until hopefully we have a system where we can no longer think of possible attacks that we don't have defenses for. However, there are many attacks against remailer systems that are very difficult to prevent against, but also many attacks which are not really feasible except under very specific circumstances, or only are feasible if you have a certain level of ability that some attackers may have and some attackers may not. And then there are some attacks that are just, at this point, not really preventable. The main one being the intersection attack that we talked about that's very problematic. But when implementers are sitting down to figure out what attacks there are and what attacks to prevent against, the ones that really need to be focused on are the ones that are most likely to work. But in order to know which ones are going to work, we also need to step back and figure out who is doing these attacks. To analyze our users and what their threat perception is. Who are they afraid of? Who is our user's adversary? Once we can establish that, we can then go through and determine what is the attacker's capabilities. Where does he sit as far as his level of competency and capability in attacking the network? What kind of damage can he do? Often there's attacks which can weaken the system but not compromise it, which usually over time lead to a compromise, but initially are not devastating. And then what kind of trade-offs can we make reasonably between performance, reliability, and cost? And I'll talk about cost more. Cost is not just fungible expenses, but also time, effort, level of difficulty, installation of new software, and so forth. I break our types of adversaries down. Roger had a list in the previous talk of the various different axes of attack capabilities: active, passive, internal, external.
Global, local, static, adaptive.
Static, adaptive, yes. We pick three archetypical attackers here. There's the global observer, whom we believe would have an omniscient network view, can see the entire network. It doesn't need to be the entire internet, it just has to be the entire network of nodes in an anonymity system. And importantly, can actually process the data he's recording. If you have, for instance, somebody with a network sniffer attached to every remailer, a carnivore-like device, recording all the traffic going through and watching it all, that doesn't really do any good unless they can then take that data and get useful information out of processing it. So they need to both be able to monitor the network and interpret the data. We're not going to go too deeply into a global observer who can do much attacking as far as active attacks and so forth, though we will discuss some of that. Then there's the external attacker, who doesn't have any particularly special advantages, but can send messages into the system, possibly delay messages going into the system, and observe what comes out of the system. And then we have the rogue operator. This is somebody who runs a node or series of nodes and knows everything that an operator knows, is privy to all of the information that a node would see that the external world wouldn't. And we'll talk about some blending of these possible attack adversary models here too. There's three main attack goals when you're attacking an anonymity system. The first being, of course, breaking anonymity. You want to perhaps compromise a group of users. You know that there's somebody sending these messages, you want to know who it is, or you know that this person's sending messages and you want to nail them, so you want to go and figure out what they're doing. You may want to see everything. You may want to just render the anonymity system completely ineffective and observe all the traffic and know what everybody's doing.
And there are lots of different ways of looking at that sort of thing. If you start, maybe you could say, I've got this sender Alice and I want to know who she's talking to. Or maybe you say, I just got a message and it seems maybe correlated to somebody interesting. I want to know who sent it or where it's going. Or maybe there's this guy who keeps receiving mail and I want to know who the people sending the mail to him are. So there are lots of different things that you might want to learn in terms of breaking anonymity.
In the theory aspect to this, we focus purely on what ways can you break the system using the system. There is, of course, in the real world, a wide variety of other ways you can break anonymity that don't involve breaking the system at all, and we need to keep them in mind when we're designing these things, because if there is an out-of-band attack, which is far more devastating than the ones we're theoretically trying to protect against, that needs to get factored in as far as threat model analysis and attack trees as well. I put down in here conditional or revocable anonymity under the breaking anonymity aspect, because there's been a disturbing trend recently in the theory community to trying to build anonymity systems which, under certain circumstances, will allow some authority to remove a user's anonymity. We basically face the problem that we don't know how to build strong anonymity systems in a foolproof manner yet, and yet we're trying to now build anonymity systems which are secure but also insecure if we want them to be. That's a very dangerous path.
Yeah, the motivation there is that there are large anonymity infrastructures, say in Germany, and they have millions of users, and at this point they want to become a little bit more legitimate in the eyes of the government. So they say, well, we've got a mixed cascade, there are 5 hops, we put the hospital in charge of this hop and the Defense Department in charge of this hop and the university runs the 3rd one and so on. And then they all have a policy, a contract, where they'll all get together when somebody complains enough and has a legitimate complaint, and they'll unveil the guy who did it. But otherwise, you can be certain that it was an okay anonymous transaction. The idea there is, well, we were probably getting a bit off track. I'll get into that later.
Yeah, many of the same concerns with this existed with key escrow and so forth, and it all comes down to just opening more uncertainty in a system that's already uncertain. That's all I really plan to say on revocable anonymity, but if there's more questions, I'll handle them. The second class of attacks, which is generally easier than the first, in strong anonymity systems at least, is to break utility. If you have a strong anonymity system and you haven't figured out a way to easily break anonymity of the users, the next best thing is make it so users don't use that system. Decrease reliability of the system, redirect users through a number of different methods to other systems that you can break the anonymity of, and eventually breaking utility of a system will result in breaking anonymity. You just keep moving people to less secure systems until you can handle attacking the anonymity of that system.
And also you can leave the users on the same system, but imagine you have a global system that has lots of nodes in the US and lots in North America, but also some in Austria or something, and people are using the ones in Austria and you don't have jurisdiction over those. Then you just go knock out the ones in Austria, and then people will use the ones in the US, which you're more easily able to watch.
Likewise, if you have a rogue operator who owns a certain number of nodes in the system, he's going to want to funnel people to his system. His system may be working normally, but now he gets to see all the traffic. We discussed manipulating reputation servers and statistics on servers in the previous talk. This is an application of that. The third thing is denial of service entirely. Just make the anonymity system completely unusable. That's really an extreme case of breaking utility. You just make it so this system can't be used, and people will either not have anonymity or use a less secure system. So we're going to go over a lot of the different types of anonymity breaking attacks. This by far is the attack scenario that we have the most different approaches for. We're going to talk about traffic observation, replay attacks, blending attacks, attacks on large files or different behavior. Multiple node operation, tagging attacks, partitioning attacks, intersection attacks, timing attacks, and then compromises of bottlenecks. We'll go into each of these in depth now. The simplest one, of course, is traffic observation. You just do it. You just watch the traffic. If you remember the original initial slide that we had for building these systems, you have a proxy that simply redirects traffic with the original routing information removed. No encryption, single hop, somebody watching the network just can see the message and know where it's going, and that's over.
Or somebody running a node in the network. Even if there's link encryption, you can still observe traffic, and if it says where it's going, then you win. Okay, so another issue that's a little bit more complex there is the issue of replay attacks. It's certainly in some of the deployed networks right now, replay attacks work because they don't bother keeping track of whether a message has been sent already. And if you can get a hold of a copy of a message and send it in the network, then it goes the same way it did before, and in fact it decrypts exactly the same way it went before. So even if you have a great mix that batches very well and has many messages coming in and does the encryption correctly, then it still looks exactly the same and goes to exactly the same place coming out. On the other hand, you need to be able to see the mix that it's going through. You need to be able to see the node. You need to see it coming in and coming out. Or maybe if you're just trying to attack the network as a whole, you grab a message as it goes into the network, and then you watch. Maybe it gets posted to a Usenet bulletin board, something like that. And you send it again, and it gets posted again, and you can become pretty convinced of which message it is and where it's going. Or perhaps if there's a particular recipient, Bob, that you're wondering if it's going to him, then you watch him and you send it several times. And then you can become increasingly convinced that that's the one.
Right. If your system is susceptible to replay attacks, you lose out of the bat against global observers. They see all the traffic. They can watch everything. You don't automatically lose against the other attackers, but you give them a lot of help, particularly in certain circumstances where somebody on the outside or somebody with some limited special privileges, like being able to watch what individual recipient's mailbox traffic is, you're helping them out a lot. We then have the class of attacks known as blending attacks. The simple one, of course, was the flooding of a node with multiple messages and then watching the output. If you've done this in such a way that the victim's message is the only legitimate message in that node besides the ones you own, you can discount yours, and you see the one you don't know how to decrypt is the one you're interested in, and you continue watching it. Variations on that try to attack pool mixes, which of course are an attempt to protect against flooding attacks, are the trickle attacks where you don't immediately drastically increase the size of the number of messages you have inside a mix. You slowly try to build up your messages inside that, and then you release the one you're interested in and watch it. These are designed to beat the anonymity provided by a mix. They basically make that into a single hop proxy again. You've stripped all the added protections and now can watch it.
So we should recognize that in a lot of cases for deployed systems right now, you don't have to get this complex. You don't have to send messages yourself and so on, and send lots of them and try to figure out where they're going. In the case of at least the cypherpunk network, which is used for all anonymous replying, basically the previous attack, replay attacks, will work pretty well. So if you can see where it's going, then you just keep on sending it. You don't have to resort to dealing with flooding or stopping other people from sending messages for a while, so your messages are the only ones going through the network, which is potentially quite hard to actually delay somebody else's message because they may notice that something's happening and their message isn't going through as quickly as normal. So there are different levels of complexity here depending on how easy it is to attack the network.
Yes, from the feasibility standpoint, blending attacks are much less serious than replay attacks because this requires that you have the ability to observe the nodes. It may not necessarily be a global observer, but you need to have enough observation capabilities that you can piece the puzzle together. And you also have to be able to control the traffic flow. This becomes an active attack, and as soon as you have an active attack, detection is possible.
Yeah, the blending attacks are very effective against batch mixes, where you wait until, say, 100 messages are in, and then you reorder them all and send them out. But the mixes that are out there now are pool mixes, where some messages come in, and at a certain time frame, you pick some percentage of them and send them out. So it's much harder to actually flush out a specific target message at the same time. And so we're not too worried about anonymity attacks from flooding, but we'll get into utility disruption in a bit.
There's the attacks on multiple messages, which I'm often prompted to discuss this when people talk about, well, what if I were to use this to trade wares or kitty porn in my abuse talks? The issue with doing multiple messages or large messages, which in a system like Mixmaster or Mixminion really are multiple messages, because as we discussed previously, messages get split or padded so that they are all the same size uniformly throughout the network. So if you have a 10 megabyte file, it's going to be split into a couple hundred messages, and that is detectable. If a sender, my heckler from the last talk isn't here, sadly, but if the sender is sending large amounts of files or lots of individual little messages like spam, he's going to be detected, because you're going to see a lot of messages come in and a lot of messages pop out. And if those messages are, say, a large file that are rejoined and pop out as one big file, you know that that was the lot of little messages that went in. Or if there's lots of little similar messages that pop out, a spam, for instance, you could trace that back, because there was only one or two users that sent in those large amount of messages. Now, if everyone behaves like this, if everyone's sending 10, 20 megabyte files all the time, then you're fine again. But the key here is just the meta point, which is you need to behave like everyone else. In order to have anonymity, you have to hide among the crowd.
You have to hide among people who are behaving like you are behaving. And that's the tricky point here, because if we want to have a single network like Mixminion, both for people who want to say, hi, I plan to vote for the other guy or something, and also for people who have pictures of horrible things happening in Indonesia or the McDonald's chicken farms or whatever, then they can't really blend with each other. So we need to find some way of getting that to work, and that's a hard problem. So that's something that we need to deal with in terms of getting the anonymity that the users are hoping to get from the system, and also educating them about the fact that maybe they're not blending with the people next door, even though they hope they are.
If this attack happens or is possible in your system, the global observer wins, just right out. It's also nice for rogue operators or individuals that have some sort of monitoring capability, perhaps in the ends, but not in the center of the mix, because really you just treat the mix network as a black box. You don't care where messages are being bounced around inside of it. You're looking at number of messages an individual is sending at the beginning, and then what correlation there is at the end as far as that many messages or those message sizes.
Basically, the longer you get to look at the network, the more confident you can be in your attack. And even if you're not a global observer where you can see everything, but you just happen to be able to see enough that eventually you'll gather the information, then it can still succeed. So that's a big issue.
And then we have rogue operators who run multiple nodes. In our current deployment, the Mixmaster deployment, registration, there is no real directory server. There are stats servers that list remailers, keys, and their reliability. And people get on that by setting up a remailer and joining the remailer operators list and announcing, hey, I have a new remailer. There is some human interaction there with the remailer operator. So there is some social engineering that would have to go on if you're going to run multiple nodes. You'd have to have multiple different personas, but that's fairly easy to pull off. As we move toward Mixminion, the whole automation process for signing up your remailer with the directory server becomes less of a public human interaction thing and more of an automated software issue. So this problem actually becomes more severe because they don't even need to pretend to be different people.
Even if we have the software to let people sign up automatically, we can't use it. We have to have a human in the loop. so that you can notice that, oh gosh, this guy in Taiwan keeps signing up more nodes. Why does he have 40, 50, 60? Gosh, he owns most of the network now. We need to be able to notice that sort of thing as soon as it happens. So currently we manually approve each new person when they arrive. And it's not that bad because each person has a public identity key which they use to authenticate all future things. So even when they rotate their keys and so on and send us new information and send us, I'm going to be off the net for 3 weeks, so don't put me on the directory, things like that. All of that can be automated. It's just recognizing the initial addition to the list that's the human part.
I promised you I'd talk about actual attacks we're seeing, and here's a good point to begin discussing some of the actual attacks. There is a lot of drama in the remailer operator community because you have a lot of people, anybody can run a remailer as long as they have the resources and a friendly ISP. And a lot of these people are, not all of them of course, but some of them are a little bit strange. So you get a lot of conflict between people that are inherently a little more paranoid than your normal population. But there is one individual remailer operator who has had his fingers in most of the attacks and problems with the remailer network over the past few years. One of his first public mistakes, perhaps, was to set up 2 remailers and run them to do analysis on flooding. His story was he had his main remailer, the Frog remailer, and a backup remailer, which he didn't announce as being his own, and then publicly announced to the world, I've caught a flooder. This is his name, this is what he's doing. And people asked, how did you catch him? And he explained that he was watching mail come into Azerty, his first remailer, and then was able to realize that mail going out to a separate remailer was then coming back from that remailer to Frog. So even though he didn't have a full network view, being a rogue operator owning 2 nodes in a 3-node chain puts you in a pretty good situation. I don't recall whether the person he outed actually was a flooder or not, but there have been a number of cases where people have been perceived to be flooding and have, because they're behaving differently than everybody else, are visible as far as who they are to the operator, and the operator has contacted them, and it turns out they're not a flooder. They're publishing a Cuban political dissident newsletter. That was the most recent one, or that sort of thing. So any remailer operator who publicly outs somebody as being a flooder is taking a huge risk there. But that demonstrates the vulnerability that the remailer network has to rogue operators running multiple nodes under different personas. And it also stresses the point that using 3 hops in your chain is not safe enough. Of course, then there's the other point about running multiple nodes, which is you can then, if you have enough multiple nodes, even with a long chain, you could perhaps end up getting users to use a chain that consists entirely of your nodes. They could be using 5 hops, they're pretty safe. Whoops, they've got all of your remailers, particularly over time if you're changing your routes. You run into statistical problems, as we discussed before.
Yeah, the math is not in your favor in that respect, because even if you choose 5 or 6 hops or something, then over time, if the adversary owns a reasonable percentage of the network, 10, 20%, something like that, then you will choose a path that has all him. So it's actually trickier than that here. We don't actually know the answer to how to fix this. It's not as simple as I just described with, well, put a human in the loop and notice when the same guy is signing things up. First of all, because they could sign them up from different email addresses and act like different people and we'd never notice. But also, even if they say, hey, I'm running 2 remailers, it's me, do what you need to do to get the anonymity to work out, I don't know the answer for that. Because there's this guy in Europe and he signed up his personal machine for a remailer and his company machine for a remailer, and he said, they're the same me, do what you need to do. And on the one hand, I can treat him as one remailer when you're picking nodes. And that means that each of those will be used half as often as other remailers. So I'm actually not making use of the extra resources that he's providing, though I am making use of the extra jurisdiction. Or I can say, great, you're providing twice as much, I'll give you twice as much traffic. And in that case, what do I do when he signs up a third node and a fourth node and he says, oh, hey, I work at all these different companies and look, I've got 58 different remailers for you. You've got a lot more ability to handle resources now. And it just so happens that I now have the ability to read all the traffic on the network. Do I want to let him do that or not? Surely there's a trade-off somewhere in there, and we don't know the details.
Part of that is the perception that the more nodes, the better. And while that's true from one perspective, which is the more remailers we have running, the less likely we'll ever end up without enough remailers running because they shut down either because of pressure from their ISP or because of just hardware problems and so forth. But you need to have a ratio of users to nodes that allows you to have a strong enough anonymity set per each node. And we don't really have numbers for that. But you do not want your number of nodes to be such that the number of users using any given chain is diluted enough to be a problem.
Well, the numbers on that are hard because they're a function of what you think the adversary is doing. And it depends how paranoid you are.
Question over here?
All the remailers have it? What do you mean by a different number of hops? Oh, well, there's a worry there. Imagine I go to the directory server and say, hey, who can I use on the network? And it says, here are the 100 mixes. And now you pick the 5 that you're going to use, and you ping them all, and then you use them. Somebody watching you just knows all the nodes you just picked because you just pinged them all, and he saw that. So you really can't go to any of the nodes beyond your first node, or you're revealing what they'll be. But it could be that the directory server could try to figure out. Yeah. Well, why don't we just trust the operator of the directory server to say, well, that one's in Taiwan and that one's in Canada?
Yeah, that is actually already done right now. There is a remailer operator in Italy who keeps a list of where all the remailers are, and you can go and then view that web page and confirm it by looking at them. And he actually lists the ISPs that they're hosted at, because it may be good enough for you to use remailers that are all in California, but at just different ISPs, because your concern is you don't want some sysadmin somewhere to be snooping you.
Or maybe you're happy that the MIT Lab for Computer Science is running one and the MIT Media Lab is running a different one, and you don't think they're going to collude, so maybe those are fine separately. Dan?
Can remailers detect when they're talking to another remailer as opposed to an endpoint? The answer is yes, mostly. If the remailer is announced, so in Mixmaster, it's more difficult than in Mixminion, because we have the link level encryption between nodes, and you could put authentication in there, and you'd know that you were talking to another remailer. In Mixmaster, the software isn't that smart right now, but could be if it were desirable.
You understand why I bring it up, because that way you never know as an endpoint, as a remailer, who the endpoint is. You just know that various people are giving you mail. And there might be a central directory, the idea that there are multiple directories.
In practice, that doesn't work.
And there are also partitioning attacks that we presented in the first part of the talk that are bad news for that. The basic idea is you need everybody to know all the nodes, because otherwise the clients can't randomly pick paths that are convincingly like the paths picked by other clients. Okay, tagging attacks. We talked about them a little bit in the first part of the talk. So basically, lens analogy here, if you take your 52 card deck and you go through and you stamp a hole in one of the cards, and then you turn them all over and you shuffle them a lot, you can look through for the one that has the hole in it, and who cares what's written on the other side. There are a number of different ways of doing this. In the Mixmaster scenario, the problem is that the header doesn't have the hash covering the right amount. So the message, even if it has been tagged or stamped with a hole through it, continues to go through the network until somebody at the end recognizes it. And the problem there is the adversary can run the first node where he stamps it, and the last node where he looks for messages with holes stamped in them, and can figure out which one's which.
That, of course, is an attack that presumes that the adversary is running the first and last node and is able to watch this. And whether this means anything or not is up for debate, but running a mixmaster node, I do see 1 or 2 messages a day that come through that are malformed messages that are not decryptable because of a problem with garbled bits. That could be a tagging attack that somebody's trying. That could be a problem with the SMTP infrastructure that we overlay upon. However, these tagging attacks do leave some sort of evidence that this is being done if it ends up going to an exit node that isn't controlled by the adversary, and makes a bet that really is probably the wrong bet, that you will own both the first and the last nodes.
Yeah, tagging attacks are pretty esoteric at this point. You're probably not going to see them because people don't need to do them. They've got easier attacks to work on.
Yeah.
They can flood things, they can blackmail somebody.
We'll get into that toward the end of this talk. This is one of the attacks that, if you can fix it without sacrificing anything, do it.
Yeah.
If you can't fix it without sacrificing other important things like usability and so forth, it's not really a serious attack as far as real-world execution compared to the other attacks.
Yeah, it's a snag in improving security of these things, but it's not so serious in the real world.
But the nice thing is that it is an attack that a rogue operator who owns multiple nodes can do. Does not need to be a global observer. Any attack that doesn't need to be a global observer is, of course, more serious than ones that are only able to be perpetrated by somebody who sees the entire network. Here's the disturbing one, partitioning attacks. Well, one of the disturbing ones. If you can divide anonymity sets, you're better off. If you can determine that this group of users and this group of users are separate, even though they're using the same infrastructure, you've cut your work down to half there. There are many, many ways that you can introduce partitioning attacks. If you have different clients that implement the protocol in such a way that it works, but it's slightly different. If you can observe that this message came from somebody using this version of the software, and this message came from somebody using that version of the software, you've now divided your anonymity set.
And this is really tricky when it comes to, say, software like PGP, because different versions of PGP encrypt stuff differently and look different. So when your PGP signed mail comes in saying, hi, I'm a guy over here and I'm anonymous, but I need to tell you this, then you say, well, gosh, he's running 1.04G, and the only people who downloaded that were these 8 over here, and now I'm pretty sure I know who it is. So that's a variant of the I just signed my name on the message, oops, attack, but it's a little bit less clear than that.
And there's even more simply than what version of PGP or how the PGP signature is made, what headers you have. If headers aren't completely stripped, how things are formatted within your message. If there's standard formatting or typo correction in your software, you can figure out what mail client somebody's using and so forth. Now, is that really a big issue? Not initially. If I go and use an anonymity system and come out of it, rather than being just an anonymous user, but an anonymous Eudora user, I haven't revealed my identity, but I've given a clue to an attacker. These add up, and over time, they become serious.
Yeah, on the other hand, I mean, there are some other perhaps more serious issues than I'm a Eudora user. I mean, if you send mail in a different language, that's pretty important. And if you send mail with a certain writing style or knowing certain information or something like that, then,
those are all out-of-band issues that these systems don't actually try to solve. If you have a particular writing style that can be analyzed as being with high probability belonging to you based on other writing samples of yours which are publicly available, you're in trouble. And no amount of strong anonymity system is going to protect against somebody just doing text analysis on your writing patterns.
They're out-of-band attacks, but because they work so well, this is not so critical to solve, because there are, you cannot simply solve this issue and have the other issues solved.
Right. We can ignore the out-of-band attacks in theory, but if we can't solve them in practice, we at least need to be aware of them before we go and try to solve other problems that we think are really serious if they happen to be much less feasible than the ones that we can't solve. Partitioning attack aspects that we can address, or should at least think about, are, we talked about the timestamp issue with Mixmaster. We talked about the key rotation aspect as far as getting users to behave differently by watching when they're encrypting to a key that's about to expire or is just been released, and perhaps stepping in, grabbing a message and delaying it so that it's sent using an expired key when everybody, or a key that's about to expire when everybody else is using the new key, and so forth. These are all problems that there are no elegant solutions to, but they need to be considered.
Okay.
Oh, I will just make a point. We had a discussion recently with the IETF as far as OpenPGP is concerned, with introducing more cipher choices and compression algorithms and so forth. These aren't security issues, and they may or may not be compatibility issues, but again, compatibility isn't the same as making sure that a client is identical to another client. It's not sufficient they just be compatible. They need to operate exactly the same way, so you can't distinguish
Allowing
which client.
options is bad.
Right. The Type 1 system has many different ways you can structure your message and ask for the individual nodes to do different things with that message, and you end up with users basically behaving very differently from each other. And if you have the observation capabilities, which don't necessarily need to be global, you can then figure out who's doing what. I can't believe that's happening.
But on the other hand, we should keep in mind that if you have 100 messages coming into the network and you can partition them into a group of 40 and a group of 60, you're still doing quite well in terms of security compared to attacks where you can partition them into 100 groups of 1. So partitioning attacks are scary from a research perspective because we want to not have too many of them. But there are other attacks that let them identify the actual person who did it, and we need to deal with those even more. Do you have a question? Okay.
Okay, so the partitioning attacks really, any partitioning attack by itself isn't that scary, but they're a building block for intersection
For the
attacks.
intersection attack, yeah. So we've talked about this quite a bit already. This is the killer attack from the research perspective. It may be the killer attack from the practical perspective also once we've resolved the other attacks. Basically, there are a number of ways of doing it, but the basic idea is users do the same thing more than once. And if they ever do the same thing enough times, where enough is a function of how much of the network you can observe and how unusual they are compared to the other users in the system, then you can narrow down who it is pretty quickly. An example of the intersection attack in terms of long-term issues is, let's imagine a user goes to CNN every morning when he gets to work at 9 a.m. And so every morning there's some guy who gets to work at 9 a.m. and CNN website gets hit. And then one day this guy goes on vacation and the CNN website doesn't get hit. He just pretty much got uncovered at that point. And so the moral of the story is that the user has to do the same thing all the time, forever, and if there's any discrepancy, then he's going to get uncovered.
That sounds really scary, but it's actually not as scary as one would think in practice, because intersection attacks really are pretty difficult to do in most cases unless you're the global observer. If you can't watch somebody at the sending end of it and at the recipient end of it.
And what we mean by global observer there is a lucky adversary. You don't actually have to watch all the network. You just have to be in the right place at the right time.
Right. You could be a rogue operator that owned, consistently over time, owned inputs and outputs and could figure this out. But
Yeah,
it's only really in the bag if you're the global observer.
It gets harder and harder as you have less and less capability.
We have a big attack here, which is mostly against the low latency systems. We can do a lot more to protect against this if we have high latency systems that can have pools which grow over time if they're being flooded and so forth. But in a system where seconds of delay mean that people won't use it, we have much less ability to protect against basic statistical analysis of remailer traffic. If somebody's requesting large files through the remailer network, you'll see the spike in the noise there.
From the perspective of lower latency systems like web browsing systems, first of all, the easy attack is you happen to be on the front and the end of the path, and you see 489 kilobytes go this way and 489 kilobytes come out this way. So, I mean, even if the timing is messed up a little bit, you can count and compare. And the timing isn't going to be messed up that much because your user has to actually be comfortable using the system. So you can't slow them down more than a fraction of a second. And even if you don't pay attention to that sort of packet counting attack, maybe you don't bother seeing the web server, you just look at the beginning and you see, oh, he just downloaded 409 bytes. It happens that the CNN front page right now is 409 bytes. I bet that's what he got. And particularly when you see patterns of 409 bytes and then 341 bytes and then 4,312 bytes, you can say, oh, that's the CNN front page plus the 2 pictures they've got on it right now. So you can start dealing with that sort of attack with all the different padding approaches we've been talking about earlier. But when it comes down to it, for the most part, they don't work against low latency systems if you want them to remain usable.
The last attack we have listed here is the bottleneck compromise. In an ideal system, you don't have any node which is more important than any other node, because if you ever have a node which is of greater value, then that's an appealing target. They can get more out of compromising that than other ones, so they'll focus on that. It's an economic decision there. If you have a NIM server system, the NIM server is obviously a bottleneck. All the traffic goes through that for that NIM server, and that's an appealing point of attack because you can learn a lot by owning a NIM server. You can't win by owning the NIM server, or else then the NIM server operator could just be evil, and then that defeats the first assumption, which is that no one operator wins. But it's an appealing position to be in. Other examples of bottlenecks are the crossover points. You learn something additional when you're a crossover point. Having that gets you a slight advantage. If you are a remailer which is consistently at the top of all the stats servers and therefore gets more traffic, I notice that when my remailer is at 100% reliability, I get about 10 to 30,000 messages a day. If my remailer is down at 98% or 97% reliability, basically some pinger hasn't gotten its message back yet because it's been delayed for too long and it thinks it's lost, I drop and I get 3,000 to 5,000 messages a day. So that indicates that people are heavily focusing their traffic on the top 99-100% reliability servers, and the ones that are there consistently are an appealing target if they aren't already being run by a rogue operator.
Yeah, so I mean, that's what we worry about in terms of getting the right balance between giving people the ability to have reliable message delivery and giving people the ability to have lots of jurisdictions involved and lots of different nodes involved in the transmission of their message. And which one the person should want depends on what he's trying to get out of the system. Unfortunately, if you've got people trying to get just a little bit of anonymity out of the system and they're happy using the reliable ones, and people trying to get a whole lot of anonymity out of the system and they're unhappy using just the one run by their federal government organization, then how do we balance these two? And that's one of the big trade-offs.
So to recap here, we're at the end of the anonymity breaking attacks. Let's look at these from the point of view of which ones are the most feasible. Clearly, traffic observation is a big one if you have the ability to sit and monitor traffic. That's clear text, and you can see the traffic, you win. What do the users need is the biggest question, and we need to ask ourselves that. If the concern, I think that generally the main concern that anonymizers users, for instance, have is they want to make sure that their information isn't being harvested by marketers. And then there's some of the people that are hiding from their boss or from their spouse or from their kids who run the computer and don't want to know that they're downloading goat porn. Their threat model is much lower than what we're trying to address in theory. They don't care if the government knows that they're doing this. They don't care if their ISP knows that they're doing this. They're worried about certain individuals who don't really have any attack capability, but
they're pretty good at traffic observation.
yeah. So traffic observation is an important part. You don't want to have unencrypted proxies because that tells your boss what you're doing if you're trying to be a whistleblower inside a company and going to a whistleblowing site. You want that to be hidden. Replay attacks. Well, depending on what you're doing with the system, replay attacks are either really serious or not very serious. If you're doing anything which is observable from the outside, replay attacks are serious. If you're posting to Usenet anonymously and you're worried about your identity being compromised, a rogue operator can do that. He gets to see your message, or even your ISP, which is receiving your messages when you're sending them into the network. They get a copy of your message. Anybody who can get a copy of the encrypted message known to be from you can attempt a replay attack. Whether they will actually get anything or not depends on where that message is going. If it's simply going to a NIM somewhere and then being sent on, they don't get anything. But if it goes out to Usenet, they can just see it publicly. If it goes to a user on the same ISP system, for instance, they could see that. It's all a matter of degrees and what user behavior and expectation is. Blending attacks are really not a big concern for most users. It's only really the more capable adversaries they can pull them off.
Yeah, most people using anonymity systems these days, from my experience, are using them so that the recipient doesn't directly get the communication. And as long as it bounces around through some nodes, then they're happy. And who cares if it bounces around with a bunch of other adversary messages and some really powerful adversary learns it. It still isn't directly linked to where they sent it from, and that's good enough.
Attacks on multiple messages and large files is a big one. Basically, you lose. Don't send large files. Don't send multiple messages.
Unless you can get everybody else to do it too.
Right. If we had a system where everybody was sending lots and lots of messages, then the people who want to send pictures of the abused chickens on the chicken ranch farms, it would be safe. But right now they have to fear the chicken co-op cartel because they will stand out, particularly to the remailer operators. Tagging attacks, we already said, aren't that big of a deal, simply because these other things are so much easier. Why waste your time on something that isn't guaranteed to work when you can deal with these other issues? Partitioning attacks and the intersection attacks require the ability to actually get this data and do something with it. A global observer who, or somebody who owns multiple nodes, who can analyze the data and do statistical analysis over time will learn a lot, but most adversaries in a given user's threat model don't have the inclination to do this.
Most adversaries are maybe a website like DoubleClick, and they're getting plenty of information. So what if 0.1% of their users don't give the information? They don't have any need to go collect it from traffic analysis.
So the next class is utility breaking attacks. We have economic attacks, incentive attacks. We have reputation attacks, which is more of a social issue, but still important. There's flooding attacks, and then there's the concept of shadow networks.
So the idea here is, we talked about it a little bit in the first part and also at the beginning of this one. The basic notion is if you've got an anonymity system that is reasonably secure, maybe we fixed some of the attacks, all the easy ones, then maybe the best attack against that anonymity system is to send people off to an easier system. Maybe we deploy Mixminion and it's really tremendously secure, and you maybe show up and flood it or smear its name or all the other ones we're about to see soon. And you say, hey, the anonymizer is a great system. Why don't you go over there? It's in the US. It's good enough for you. It's good enough for us. Why don't you use that? And at that point, you've totally gotten around all of the security that we put into Mixminion. Or you can join the Mixminion team and say, what about partitioning attacks? Those are critical. You got to fix them. And then we spend all our time working on partitioning attacks rather than deploying a usable system. And then, again, we don't have a network that users will actually want to use.
Right, most of these involve actually rolling up your sleeves, doing active attacks against people. These are mostly social attacks. Though, one thing we're seeing constantly now for at least 18 months is a heavy burst of flooding on the Mixmaster network. We have a number of very clever techniques for flooding the remailers based a lot on problems inherent in the Type 1 system that carry over to the Type 2 system because we try to support that as well, that involve directly flooding a node, or well, that's easy to stop because you see all these messages coming from one person. So you trickle messages in over time because Type 1 allows you to set a user-supplied latency. You can then stagger your trickling so that these messages pile up at the individual attack nodes, and once a given time hits, all converge on a central node to be targeted, bring it down. The idea, I believe here, I do not think this is an attack trying one of the blending attacks. I think it is simply an economic attack against the operators and the users, basically hoping to destroy the reliability of certain key remailers, get the remailer operators shut down because their ISP's bill is too much, or make it so users steer away from those remailers because the more messages you have sitting in a pool, the higher the latency for any individual message is going to be. So people, general users, want their messages to show up on their mailing list thread within a reasonable amount of time. They're willing to wait half an hour perhaps, but if they're waiting 2 days, that no longer, that comment may no longer be appropriate or topical, and so forth. Anything you can do to discourage legitimate operators to leave means there's a much greater likelihood that people are going to be using your remailers if you have some in there as well. A rogue operator has a strong incentive to make the other remailer systems look less desirable to the users. If you can discourage users, you've then got to win, because the less users there are, the less possible suspects you have if you're trying to pin a certain message to an individual user. Just like with partitioning attacks, you want to cut your anonymity set. If you can just cut people and get them to leave, you then win. If it's the person you're looking for who leaves and goes to a different system, you just follow him, watch him. If these are just unrelated people, they no longer provide the cover traffic. So a good system will try to protect against all of these things as well as the security issues. And then there needs to be the balance between what do we do if there's a security issue and an economic attack that can't be solved simultaneously. It's one or the other. We have reputation attacks. These are fun too. Many of you are interested in examples of reputation attacks. You can go to Google Groups, and type my name in there, and you will see some delicious, delightful reputation attacks against me, which are interesting. Very similar attacks, basically the same attacks are happening against a number of other people, all of whom have in common the fact that they are actually developing remailer software, remailer clients, or in some way contributing significantly to the remailer network. The intention here is perhaps to discourage the people that are being attacked. Maybe I will get tired of being accused of being a Scientologist, FBI, narc, DEA agent who is, I forget the rest of it. It was really long, rambling. I'm sorry? If only it wasn't true. Right, yes, I work for so many intelligence agencies, it's not funny. No. That's not going to happen. I'm not going to get discouraged and walk away because somebody says something anonymously on Usenet that is just absurd. I've also been accused of single-handedly causing the demise of PGP, which I thought was great too. But the one thing that it can do, that it will be more successful at, is if you create lots and lots of FUD, fear, uncertainty, doubt, about a system, about people behind the system, about operators of the system, you may just confuse the users out of existence. They hear all these conflicting bad things about the network, they don't know who to believe, they go elsewhere. You've just driven users away, weakened the system, and moved the users to weaker systems. Question? I believe that it is one of the likely motivations. I've done a lot of thinking about what the motivations in these given attacks are, and every time I come up with what I'm convinced the real motivation is, something else happens that makes me doubt that. So speculating about what these attackers' motivations are is dangerous, but I can weight them. I think that the motivation behind this attack is more likely to be to drive users away or to stop individual key contributors from continuing to contribute and develop these things, rather than, say, being intended to perpetrate a security attack and so forth. Right. As you go down the path of how do we build an anonymity system which will beat the global active attacker, you end up providing FUD fodder.
Yeah, we see that in security.
The first question is, does a global active attacker that can analyze the entire emailer network and manipulate the traffic and figure out who everybody is exist? Second question is, does anyone actually fear that attacker? I think that at least one of those questions is, the answer is no. But if you can convince the end user who's trying to hide from his boss, or even the political dissident who operates out of a country which in no way has these capabilities, that he actually has to fear them, then he will become scared, and if it's his job or his marriage or his life on the line, may walk away from the strongest anonymity system for him and go to a weaker one that he understands better because of the FUD being spread, which is based on legitimate research findings.
Yeah, it's not just in the research community that happens. I mean, I've been watching At Stake put out security advisories about things I've known for 10 years, and they get all sorts of publicity. I just found a huge hole in this thing over here. And I say, well, yeah, we all knew that. But there are a lot of users who say, whoa, those guys are really good researchers. They found a hole in this thing that we've been using for a long time.
Or for instance, there's a certain AT&T researcher who got a lot of press early this year for discovering a great vulnerability in locks.
Yeah.
And got a lot of press and a lot of people scared that anybody could very easily open the locks to your door if you're in an apartment complex, and really demonstrated that he doesn't understand threat model analysis at all. Scared a lot of people, but didn't actually discover anything new. This attack was known for a while, and of course, is harder to pull off than jimmying the door jamb, or opening the window, or conning the maintenance person into opening the door for you. You need to, my suggestion to this researcher is to do an attack tree on breaking into someplace and figure out where his lock technique sits. It's a clever technique. It's not to put down the research, but the actual practical implication of it is not nearly as significant. And that's the main point that we have here, is there are all these attacks. You need to weight which ones are the most likely to occur, most feasible, most economically sound for the attacker, given whatever that attacker's motivation is, and assuming that the user cares about that attacker. And then what can you build based on that?
A lot of it's about education of the users, because if you come up with a really cool-sounding attack that doesn't actually matter, and then the press says, wow, that's something I can grab onto and understand, and I'm going to publicize it, then it isn't really as important as maybe it should have been. So you got to make everybody understand the issues, and that's hard.
We're going to take the rest of the questions at the end since we're running out of time.
Okay.
There's the flooding attacks, and I'm going to address these separately from the flooding attacks that are part of blending attacks. These are just simply attacks to limit usability and utility. You want to exhaust node resources. If you flood if you saturate the link that a remailer has, you're preventing legitimate users from getting their mail in, and you're causing a lot of pain for the operator because now he has a huge bill. Or if he's running multiple things off of that service, access to his other services are denied, and he may decide that shutting down the node is the proper thing to do for him. It can harm node reliability. If you overwhelm a server and it falls off the net, it can't process mail. There's the issue of abuse complaints. Now, if we're back to the spam issue again, sometimes abusing end users can actually be an attack on the network. If you create enough abuse complaints and get enough pressure from ISPs to shut down remailers because of abuse, you've actually just used the users and abused the users for the sole purpose of hurting the network. So that can be an attack. There does have to be dialogue and conversation between the operators and their ISPs and their local law enforcement. And again, a good review of this is in the previous year's Black Hat proceedings. We can do flooding attacks for economic reasons. We can do it for reputation reasons. You can attempt to flood the network through a certain remailer and try to pin that flooding on that remailer operator. So it becomes much more simple to flood a network if you run a node, because you can then say, well, no, it's not me. It's just somebody else sending mail through me. There's always that doubt, and likewise, you can turn that around and pick an innocent operator and try to convince the other operators that he's doing the flooding. We're seeing this right now as well. There's a lot of back and forth finger pointing between who among the remailer operators is a given flooder, since it's nearly certain that this flooder is somebody who is a rogue operator. If you can knock certain nodes off the net, you basically can aid yourself in trying partitioning attacks, intersection attacks, and so forth. And a lot of these problems don't need to exist, but do exist because of what were originally perceived as useful additions to the Type 1 protocol. For instance, the ability to select a certain additional amount of latency time that a message you send will have. All of those can be brought to an extreme which will allow you to completely shut down remailers too, which is the complete denial of service to the remailer network. We don't have a slide for this, but the shadow networks.
When a user shows up and says, I just downloaded my software and I want to use the remailer network and I'm going to send a message, and he goes off to the directory server and says, hey, tell me all the nodes I could use, and if his software that he got points him at the wrong directory server, he's screwed. That directory server gives him a total different list of nodes. He uses the total different list of nodes, all of which are owned by whoever owns the directory server, and that's that. We have the same problem with introduction in peer-to-peer networks. How do you figure out which Nutella servers are the real ones, not the ones run by RIAA? So that's an issue, and I don't think it's a serious one. We can hopefully solve it with public key crypto. You get the software distribution from the right place. You don't get it from the wrong place. But it's definitely something to pay attention to.
It is a big issue, and the nice thing there is you can get a user to just sit on your own little private network, and if he doesn't realize it, you win, because everything will behave the way he expects it to. It's just
he's happy,
not where
happy.
he thinks he is. So when analyzing these things, as I've begun to mention, we need to look at the types of attackers: global observer, external attacker, rogue operator, and their goals: compromise of anonymity, denial of service, degradation of utility. And then we need to look at our users. Attackers are going to pick the type of attack which will most easily and most successfully achieve their goal. So, and what attackers do we have to face, and what are their goals? Well, we can't really go and ask the attackers, what do you want to do? But we can ask the users, what are you afraid of? What is it you want to protect against? What do you need to prevent? From that, we can then build a profile of our attacker. What possible capabilities he has, what his potential goals are, and then from there, go back to our list of different attacks and figure out which one is the most likely to occur. Basically, we need to identify what information we're trying to use as the root of our attack tree and then build an attack tree out from that. Every time we do anything to fix security that results in making the system harder to use, requiring people do something extra than they normally do, we need to evaluate. Is that allowable in that user's motivations? I mean, if he's really serious about his anonymity, he's willing to go further than other people. And then, of course, even if somebody's really serious about their anonymity, are there enough of them that it matters? Because we do have to hide amongst the crowd. There's lots of variables to pay attention to here. But the key thing to come away with is users will say that they want strong anonymity, etc. But you need to figure out for the user what his priorities are. If his priorities are that when he sends email, it gets there in half an hour or less, and that's that, you can't compromise on that. You have to build a system within those parameters, or you'll lose the users. As you lose any kind of security system that's too hard for a user to use, fails because people don't use it. But it's particularly dangerous with anonymity systems because when you drive users away, you harm the users that still exist. So to sum that up, if they're sacrificing usability and reliability, and the reason they're sacrificing these key points is to protect against attacks such as the tagging attack that don't really exist in practice or don't make sense to exist in practice if there's a more feasible attack, then they're flawed because they are, for no practical reason, making the system harder to use. And they are getting less users than they would have if it were easier. There is a very serious correlation between ease of use and number of users. It's why they're called users. So you want to strive for the strongest threat model possible with the constraints. If there's an attack, for instance, the tagging attack again, where the fix for it is trivial, it doesn't actually hinder usability or make anything more difficult, go for it. Please make the system as secure as you can, but every time that you have to ratchet up the level of difficulty to use the system, really think about why you're doing that and if you need to do that within the threat model. Zero cost improvements are good. Anything that costs usability, reliability, or opens up other potential problems such as another avenue for abuse, another avenue for resource exhaustion, etc., needs to be seriously considered.
Okay, we've got a bit of time for questions. I believe on some peer-to-peer networks, yes. On mixed master networks, not that I know of.
In other words, as a message hits node, the second message to that is attached that moves backwards. Because each node knows where a message came from and where it's going.
Mm-hmm.
Neither of those are secret. So as you send a message forward, at the same time, the original source attached a message that goes backwards all the way back.
The way you would want to do that is instead you'd want to have extra functionality at the mix level where you have maybe a public key that's going with it, and then you encrypt information to that public key at each hop, and then it goes in a circle back to you, and then you've got it all. Problem is that the public key is linkable at each point.
You would need cooperation from the nodes
Yes.
to do that.
And
The
you
nodes aren't
also
gonna-
are introducing options which are dangerous.
I'm just saying, if you're already sending a message in one direction, by sending it in the other, you're able to support people's work. You're able to support nodes that are less reliable.
You're able to support receipts.
It's
Yes.
exactly the same as X25 where you have lots of unreliability. You need to have, instead of having end-to-end error detection, you have to have hop by hop.
Okay, I see where you're going with this. There is actually another approach, which is you allow the users to pick a random identifier for each hop, and you get the nodes to publish their list of random identifiers. And then the user can then see, okay, if that went through there, the random identifier should be published, I should know it. And if it's not there, it's not there. That also can be...
Sure. I mean,
Well, you publish it for that day, or for, I mean, you don't keep it for a long period of time. A user's not going to care if a message was dropped, a week ago. if he cares, he's going to check. But these are, on the scale of things to do, that's not on the high priority list.
Yeah, remember from an anonymity perspective, if that user only goes and checks the logs of 5 mixes in a given day, then those were the ones that his path used. So that could be dangerous.
The pingers also do chain analysis. They'll create, they'll do all of the n squared chains of remailers to figure out who can't talk to whom. That's a big issue right now with Mixmaster, because we rely on SMTP. Some of the remailers are put into the SPUs list and so forth. It's less of an issue with Mixminion because it has its own protocol, and
The
everything
director
can be
servers,
expected
hopefully.
to just work. If it doesn't, it'll be discovered pretty quickly. With the SMTP underlay, expecting it to just work is a bit of a stretch. Other questions?
One more there. If you try hard enough.